All right, let's look at how we count in probability using a tree diagram. So here's my tree diagram. I've gotten it started. We're going to be looking at meals in our example. Okay, and we start branching off from there. But just to give ourselves a little bit of context quickly, let's look and see why we want to do this. So in probability, we often want to know the total number of outcomes. So it's called an exhaustive list. It's a list that includes every possible outcome that could happen. Okay, so here's our example. We're going to go to a restaurant. Now, how many different meal combinations can we make? This would be called an exhaustive list. Okay, at the restaurant, we have 2 salads, we have 3 main meals, and we have 3 sides. It does not matter which one of these we start with for our tree. I've started with one of the 3s because it's just easier to branch my tree off that way. Personal preference, but it really does not matter. Okay, so I'm just going to use the first letter to keep my tree looking neater and simpler. All right, so I've done my main. I have a steak, a fish, and a chicken, and that's it for the main meal. I'm done. Okay, so I'm going to pick one of the next ones to do. I'm going to choose the next 3 one, which is my sides. So I can go up. All right, we've got broccoli, peas, and corn. I'm just going to use the first letter. So broccoli, peas, corn. And now I've done that for steak, but I also have to do it for fish. Broccoli, peas, corn, and again for chicken. Broccoli, peas, and corn. Okay, and now I need to include my salad. So I'm going to go ahead and branch off each one of these with 2 like this. Okay, again, I'm going to use the first letter of my word. So for a steak and broccoli, I can have house or cob. For a steak and peas, I can do house or cob. For a steak and chicken, a steak and corn, I can do house or cob. And the same thing here with fish and broccoli, right? Or fish and peas, or fish and corn, or chicken and broccoli, or chicken and peas, or chicken and corn. Okay, you can see a tree can get a little bit messy and congested very quickly. All right, now our total number of outcomes, all we're going to do is count the end of our tree. We're not going to go back here and start counting all of these. We're going to pretend like these are chopped off, and we're just going to count the end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so 18 outcomes. Yes, I could have counted by 2s to make that counting easier. Okay, I want to show you something that we have in probability. It's called the fundamental counting principle. Don't worry about the big name. All it means is that if we want to do this counting without making a tree, we just have to identify what are our main events. So here our main events are the main meal, we have a side, and we have a salad. Okay, that's usually the hardest part of the problem. What are our main events that we're looking at? Okay, and then we want to write down how many options there are or outcomes for each of these events. So for the main meal, there's 3. For the side, I have 3. Now I'm not going to do 3, 6, 9 because there's not 9 choices, even though there's 9 here in my tree. There's only 3 choices, right? Broccoli, peas, or corn. So I'm going to write 3 here. And then I'm going to look at my salad. My salad only has 2 choices. All right, now here's the cool thing. All I have to do is this. What's 3 times 3? 9. 9 times 2 is 18. All right, so we can get the same number of outcomes if we can identify what our main events are and then how many outcomes are possible within each main event.